And conjunction. What was that all about? Oh, I think I do have it. Ooh, yeah. So conjunction, what's the word associated with that? No, not conjecture. Conjunction function, junction. It says and. It's not a good day to try to say. I'm sick. And what's the symbol that we use for that? TP, right? Little A without a slash in the middle. What about a disjunction? Good. Or, and it's just this with a V. You or you, I don't care, do it. Right? What about a conditional?
If, then.
Good. Uh-oh. And then an arrow, right? And the arrow makes sense because this leads to this. It doesn't say this leads back to this. It's very specific, right? And what about a biconditional? And what's the saying?
If and only
If and only if. Which I have to force myself to write all these words out, because you'll see me write IFF. So please know that IFF means if and only if, because I'll do it without even thinking, right? And that's got the double arrow, because it goes both ways. Biconditional goes both ways. Okay, and the last little one here is the negation. What's the symbol for negation? I mean, the word is not. Wow. But the symbol is a little tilde up. Okay, cool. So a little review there. And now we can take statements and write math-looking statements out of them. And the reason we want to be able to do that is so that we can then analyze the logic easier. I don't want to have to keep rewriting an entire statement as I analyze it. I'd rather write P's and Q's as I'm analyzing somebody's logic, right? That's why algebra is the way it is. I don't want to keep writing these big numbers. Let me just write X. You know. Oh. So for example, if I had Ted is a strange man, or his social skills need work. How could I, yeah, so the first question would be, and the book's got a homework section like this. What is the name of this logic thing? What's the symbol you would use to rewrite it? Disjunction. Yeah, so this is definitely disjunction. What symbol would you use to rewrite the or?
V.
A V. And you're going to call this P, and you can call this one Q. Right? So part of your homework, really, it doesn't even go that far. It just says, what type is it? What's the symbol you would use? So that should be pretty straightforward. You just look for the ors, the ands, the if-thens, the if and only ifs. It's a giveaway, right? The one that gets a little more interesting is when they start doing it backwards. They start doing things like this. Given P is I like the Celtics, and Q is Tate likes the Lakers, and R, oh crap, R is we enjoy eating Oreos. Yeah. I must want some Oreos. Somebody, that's all I can think about. How would you write in English this? What would this be in English here?
Celtics. And
Careful now. So it's definitely an and. What's P? I like the Celtics. So I like the Celtics. And we don't enjoy eating Oreos, right? Do you guys see how that works? It's a lot. It's almost like, it's really a lot like algebra, except instead of giving you number values for variables, I give you phrase values for variables. And you just plug them in. So I like the Celtics and we don't enjoy eating Oreos. You guys see how that works? Yeah.
Where's the part, we just got rid of Q? Because Q wasn't in the formula.
I can give you values for variables. I don't have to have every variable in there, right?
Okay, I got that.
How are we doing so far? I mean, that's, once you see how that works, it should feel very familiar to you. You're just plugging entire phrases in now. When there's a little tilde, like if it was a not P, I don't like the Celtics. Right? So if I see a little tilde, I just negate that phrase. Put not or I don't. So what about this one here? I'm going to have to help you out a little bit with this one, but I want to show you the idea. Not Q or R and not P. Now in English, how do we separate ideas? What symbol do we use? Commas. I love it. So that's going to help us out with this. What ideas do I want together? These. So what is this piece by itself? Yeah, Tate does not like the Lakers. Or, and he doesn't. It's just pretending. Tate does not like the Lakers. Comma. Right? Because you want this by itself and then these together. So the parentheses actually tell you where to put the comma. Tate does not like the Lakers. Or
we enjoy eating Oreos.
Good. We enjoy eating Oreo cookies.
And you don't like the Celtics.
And I don't like the Celtics.
So how did we lose the or, the V? That's just the comma?
No, here's the or.
Oh, or, okay. So how do we, why do we put the comma before the or?
Because
It's just
we have to in English, yes, probably. So we have a little bit of, so don't get too freaked out. As long as the comma is separating this idea from these ideas. And what's in between those ideas? The or, right? So this idea is by itself, and these ideas are together, right? So I'm hoping that's not a huge deal. It's just like the comma's got to go somewhere. The grammar is not always going to be perfect, so let go of that a little bit, right? Because we're trying to go from math directly to English. It's never going to be a smooth fit. In fact, sometimes the word and can be hidden. What do I mean by that? I could have something like, I like the Celtics, but Tate likes the Lakers. What would that look like in symbols? I don't even need a comma there, really. I like the Celtics, but Tate likes the Lakers. I like the Celtics is B. What is the word but?
it's a conjunction.
I haven't taught you about but, have I? But it's another name that means and. If I put an and there, isn't it still true? So in English, the word but is really the same as the word and. It's just that I use it to kind of say, sure this, but that. I use it in a specific way to make a point. But it really could be replaced with the word and it would still make sense. right? So that's what I mean by hidden ands. When you see the word but, that's an and. So it'd be P and, what was it, Q. Right, so in English, the word but, we have to understand, is also another way to say and. How we doing? Okay, okay. So what we're going to do today, and that hopefully should take you through most of the homework there. What we're going to do today is we're going to start analyzing when certain statements are true, when certain simple or compound statements are true. So a simple statement was one that had no connectives. Remember that? So a simple statement would be Tate does not like the Lakers. Simple statement would be, well, I got to be a little careful. The simple statement would be, we enjoy eating Oreos. That is a simple statement. It's one idea. The minute I have a connective in there, or a negation, which is why I had to be a little careful, that's called a compound statement. So any statement that needs more than just one letter to represent it is a compound statement. So that's why this is not simple. Because how many symbols do you need? 2, don't you? A Q and a not in front. Right? So negation officially makes it a compound statement. How we doing? So make sure you guys are decently okay out there.
So if it's, you don't like Oreo cookies, that's 2 symbols because you don't eat the negation.
Yes, the negation of Tate likes the Lakers is Tate does not like the Lakers. So I have that explicit negation in there.
But it,
So it's officially a compound statement.
So anything with not in it is.
Anything that requires more than one symbol to write. So obviously, I like the Celtics, but Tate likes the Lakers is compound because it requires 3 symbols, right? But I like the Celtics, 1 symbol. That's simple, right? I don't like the Celtics, compound, requires 2 symbols, not P. Okay.
So compound are 2 symbols.
Compound is more than 1 symbol. Simple is just 1 symbol.
Okay.
Fine. Cool. So let me start off with the true basics here, because this is going to get not freaky. We just got to notice. We got to pay attention to what really is important at the moment. So let me start with building just the basics, and what these are called truth tables. And again, anybody that's taken philosophy before, you might have done some of this. I love the reaction of some people like, oh shit. Don't do that too much. You're scaring everybody around you. But give me a chance. Don't give up on me already. So let's do a truth table for each thing by itself, and then we're going to build some bigger ones. You really had a bad experience.
yeah, these are ridiculous.
All right. Everybody else is like, geez, man. Let's take a look and let's see what we think. All right. So first off, looking at or. So I got P or Q. Right? So a truth table looks like this. I got P. It looks a lot like the XY table from algebra. But what could P and Q, what values could they have? Like the statement, I can play the guitar. That statement can either be what or what? True or false. And that statement is very false. I know a few chords. I don't think I call that playing the guitar. All right, I can play it. So here's the trick to this. They could both be true, right?
Yeah.
So that would be one situation. They could both be true. Or the first one could be true and the second one could be false. Or the first one could be false, second one true. Or they could both be false. So one way to notice this is one of my students came up with this, because when we get to 3 letters, it's going to be even longer. Right? Because think about this. How many options are there for P? 2. How many for Q? 2. 2 times 2 is 4 options total, right? So if I had 3 letters, PQR, 2 times 2 times 2, that sounds a lot like that volume thing, because there's 3 kind of dimensions here, really, right? So it would be 8 long. Okay. But notice how this goes 2 and 2, and this goes 1, 1, 1, 1. So true, true, false, false, true, false, true, false. Right? Okay, maybe I'm just trying to show you the pattern. For an 8 one,